Okay, so we have f of x is equal to negative x plus 1. What is that? It's just a line, right? Okay, so tell me about that line. It's linear, correct? Okay, tell me about the y-intercept. Yes, it's going to be 0, 1. So let's put in, I should have grabbed some, I think this was just from the workbook, so I just used what they had. So go ahead and put in an axis, the two axes here, okay? So I'm going to start at 0, 1, okay? Just think about there would be a point there, and then the slope is negative 1, meaning I would do what? Go down 1 to the right 1, down 1 to the right 1. Here's the thing, though. It says I only want to graph this where x is less than 0. Where x is less than 0. So that means I'm going to graph this line, but only on the left side of this graph. So how am I going to accomplish that? How do you think you might want to do that? Got to be on the left side. So maybe, what if I go to where x is 0 and figure out where I would be on the graph? And we already talked about that, didn't we? It'd actually be where? It would be right here at 0, 1. Okay? Now, I need to show you something. I'm going to put a circle there because do you see how it says less than 0? So I don't actually have a point right there at 0, 1. But then my left side of that line is going to extend from that open hole. Okay, so how will I do that? I'm just using my slope, which is a negative. So it'd be up 1 to the left 1. Can I do it that way? Absolutely. So this is going to look like this. So I'm doing my best to make it go through all the right spots. I think that's pretty good right there. Now, I should technically have an arrow on the end of that because it goes forever in that direction. So there's the top graph, okay? So the line would be a negative slope of 1, and then it intersects the y-axis at positive 1. Now, what about f of x is equal to x, where x is greater than or equal to 0? So that's like the right side. And I'm going to have actually a bubble that's going to be filled in. Okay, so where's that going to be? What's the question back there? Is that your question? At the origin, very good. So I'm going to put a circle there as well, and I'm going to fill this one in because it is including that value of x equals 0. And then I'm going to extend my line, and I'm going to extend it up to the right. I'm going to do an arrow like this. And I want to go through every single, yep, that looks good right there. Okay? So that is how you do one like that. Now, these should actually be solid lines. I'll fix that in just a second. So that is a piecewise function. So literally, you just take the function and think of it how it would normally look, but only sketch it in where the domain is valid. The other approach, and I don't think you guys need to do this, but the other approach is to actually draw the whole function in and then erase where it's not valid. I don't think you need to do that. I think you may initially need to do that, but eventually you'll be fine just kind of thinking the whole thing through. Okay, look at number 2. So f of x is equal to negative 1. So that's just going to be what? Let me put my... Okay. So y is equal to negative 1. Isn't that just a horizontal line? Okay, so now, but it's only valid where x is less than 1. So I'm going to go to where x is less than 1. I'm going to put in my bubble that will be open. And the value here to start off would be the y of negative 1 that goes with it. So this is just going to go to the left like this. Okay? So that's a line, y is equal to negative 1, but only for the domain x is less than 1. Oh, I did it wrong, didn't I? Yeah, it is. Thank you. There we go. All right. Now, what about the next one? 2x minus 2. So it's going to intersect where? At negative 2 right here. has a slope of 2, so up 2 over 1, up 2 over 1. So it's going to look something kind of up through this region. But it's only valid where x is greater than or equal to 1. So this is what I would do. You have a couple of things you could do. You could draw it in and then erase this little piece of it. How about if I take the 1 and plug it into this line and figure out exactly where I need to start this line? So it'd just be 2 times 1 minus 2, so we're going to start at 0. So I'm going to start right here at a y of 0 where x is 1. So it's going to go right there, and I'm going to bubble it in. And then can I still use my slope of 2? Absolutely. So just pick a couple little points to make your line and then sketch it in place. Now, do you notice these two are not continuous graphs? Sometimes they will be and sometimes they won't be. Okay, how about the next one? This is what function? This is a step function. This is kind of a review from yesterday. Okay, so we'll just draw this in place. That's not what I meant to do. Okay, so this is just shifted up by 1. So I'm going to start right here, open, fill it in. My open will be to the right, and then it just steps up by 1 just like normal. So it's a simple little problem. But it is a piecewise function, believe it or not. It's little pieces of the line, of each line. Okay, now, write the equation for each function whose graph is shown below. So this is what we were just doing, but the opposite. And we actually focus a little bit more on this tomorrow. Now, so this first line right here, let's write f of x is equal to, and then some people like to do the domain first. So I'll kind of do it both ways. The left side of this graph, the x's are what? They are less than 0. The right side of the graph, the x's are what? Greater than and equal to 0. You see that? So those would be the domains. What is this equation right here? The intersection with the y-axis, or the y-intercept, is 1. And what's the slope? It's just a negative 1. So this just be a negative x plus 1, and I'm going to put a little semicolon here where x is less than 0. A lot of people think this way is a little bit easier, but it's just kind of up to you. Okay, now, this is a line at 2, y's are 2, and only where x's are greater than or equal to 0. That's it. You're done. Yes. Oh, yeah, you're right. It would be positive. Thank you. Sorry. Yeah, that's a positive slope of 1. And it's crossing at 1. Okay, let's do the next one. Number 5, f of x is equal to, and I'm going to need like 3 different sections of this graph. Okay? The first one, x is less than 0. The second little piece, x is between 0 and 1, including 0 but not including 1. And then the third little section, x is greater than or equal to 2. So those are our domains, but I'll write those in just a second. So this is a line crossing at negative 1, and what's the slope? Negative 1. So this would be like this. And then it's going to be where x is less than 0. Now there are other ways you can write this. I could say negative infinity up to 0, and I would not include that 0. So there's 2 ways you need to be able to write or read the domain. Did y'all see what I just did? The next one is just a line at 1, and it is valid between 0 inclusive and 1 non-inclusive. The other way you could, not 1, 2, sorry guys, this would be a 2. The other way you could write this would be 0, 2, inclusive of 0, not of 2. Now, this one, you can kind of extend this out. This slope is 1/2, y'all see that? So 1/2 x, and where's it going to cross? At positive 1, you see that? So 1/2 x plus 1, where x is greater than or equal to what? 2. Or I could do 2 to infinity, like that. So it's not so bad, is it? Now, where are you going to get in trouble? Well, if you don't remember how to write the equation of a line or a parabola, that kind of thing, it might be a little bit hard. Now, the next part is evaluating. So, let me see. So this goes for number 4. This is for number 5. Oh, we didn't do number 6, did we? Let's do number 6 down here. So number 6 is a what? Is it a floor or a ceiling function? It's a floor because it opens to the right. And it's kind of hard to say how it's been translated, isn't it? So let's just go with the simplest one. Let's just say it got translated down by 2. So this would be f of x is equal to, and this is just going to be an x here because it's a floor, and then you're going to subtract 2. And that'll work. Okay? Now, evaluating the piecewise functions is basically when you just plug in the x, but you have to make sure you know what part of the function, the domain, is relevant. So I'll kind of explain what I mean by that. So here, this is our piecewise function, and we want to evaluate it for -6 and for 3. So when I evaluate this function f for a -6, I have to figure out where is x of -6 even valid? So which of those little sections has a -6 in the domain? Is it the first, second, or third? It's the first. Very good. So it's just going to be a -8. It seems kind of weird, but it's just a line at -8, and -6 is in the domain here. What about the domain that contains 3? Which one contains 3? The first, second, or third? Where's your x of 3, guys? The first, second, or third? Second. Very good. Thank you. Oh, not that. It's a 0. So then you just plug it in. Obviously, these are all horizontal lines. Just little sections, just like our piecewise, like our step function is. But over here, we're going to have to do a little bit more. So let's evaluate these. So now I'm going to do g of -6, and then I'm going to do g of 3. So where's the -6? It's this one right here, correct? So what would I do with that? Plug in the -6, so I get what? Negative. Y'all, do you understand what I'm doing? I'm plugging in a -6. This is valid for all x's less than 2. So that means -6 is here, not here. Does that make sense? So I'm going to plug it in for this piece of the function. So 5 times -6 is going to be -30. So it's going to be -39. Are y'all getting it? Like, is it simple, or are you just quite not awake or something? Yes. You have to make sure you're going to the right piece of the function, because the domain is kind of broken up by function, by the different little pieces. Okay, what about 3? 3 is valid here, isn't it? So I would do 4 minus 3 squared, which is going to be what? -5. Very good. So 4 minus 9. Okay, let's do a little bit more from the graphing. Are y'all getting it?
I like the name.
The name piecewise? Okay, so let's go ahead and graph this one right here. So I have y is equal to 7 when x is less than -2. So I'm going to go x of -2, and it's going to be a 7, so it's going to be up here, right? We're going to start here, and I'll come back in just a second and put the little, there we go. And then the little hole will be what? So y is 7 when x is less than -2. Y is a -2 when x is greater than or equal to -2. So I'm going to come down here, put a hole, I'm going to bubble it in because the equality symbol is there, and then it goes to the right, just like that. Okay, what about number 7? X is less than or equal to 4. So this might be a good one where I could do what? plug in a 4. When I plug in a 4,